So in our lab we have these resistances available, plenty of them, so we can use as many as we require. And there's 1.8 ohms, 20 ohms, 300 ohms, 24 kilo ohms, 56 kilo ohms, and we need to achieve these resistances, each of them, by series and parallel combinations of any of these available ones. So 5 ohms, then 311.8 ohms, 40 kilo ohms, and 52.32 kilo ohms. So 5 ohms can be achieved. We can see we have these three in ohms. So if we use 20 ohms in parallel, two of them, we will get half value, so we will get 10 ohms. So if we use another 220 ohms in parallel, we will get another 10 ohms there. So what I'm saying is, we just from our knowledge, we can always use the formula, but we just know if we use two equal value resistances in parallel, we get the equivalent value as half. So with 220s in parallel, we get 10, another 220s in parallel, we get another 10, and when those two in parallel, those two 10s in parallel, we will get 5, of course. So this is how we can get 5, we can just readily say. So here we get 5 ohms. Now we need to do, let's do the second one, 11.8 ohms. So we have a 300 ohms there, we have seen, and we need 10 and 1.8. There is a 1.8 resistance, 1.8 ohms resistance. So before that we need 10. So what we can do, we can use 220 ohms again in parallel. That will give us 10 ohms there, and then we can use that 1.8 ohms. So we will get, here we get 10 ohms, this combination. So 300 plus 10 plus 1.8 gives us 311.8 ohms. Then there is the third one, is 40 kilo ohms we need. So we have the kilo ohms resistances, we have 24 kilo ohms and 56 kilo ohms. So 24 kilo ohms there and 56 kilo ohms. So what we can do, if we use 256 kilo ohms in parallel, we will get the half, we will get half value, half of that, which will be 56 kilo ohms and 56 kilo ohms, two of them. Here we will get 28 kilo ohms, and again if we use 24 kilo ohms in parallel, we get 12 kilo ohms. So that will give us, 24 kilo ohms here, this is getting 24 kilo ohms, again 24 kilo ohms, these two in parallel. So what we get here is 12 kilo ohms, the parallel combination. So 28 plus 12 gives us 40 kilo ohms. So here we will get these two terminals, we will get maybe here we get 40 kilo ohms. Finally we need 52.32 kilo ohms. So we have to remember that we have 24 kilo ohms, we have 56 kilo ohms in our lab, and we have 300 ohms, which is 0.3 kilo ohms, and we have 20 ohms as well, which is 0.02 kilo ohms. So what we can see, when we look at this value, with 300 ohms and 20 ohms in series, we get 0.32 kilos, because that's 320 ohms and that is actually 0.32 kilo ohms. So we will do that first, let's say, and then we have these 20 ohms. These two combinations, series combination, gives us 0.32 kilo ohms. So that's there. Now we need to get 52. In order to get 52, what we can do, if we have 256 kilo ohms in parallel, we again like before, we will get 56 kilo ohms, 56 kilo ohms. The parallel combination will be 28 kilo ohms. So 28 kilo ohms and 24, 28 plus 24 is 52. So if we just add these 24 kilo ohms in series, we will get our desired 52.32 here at this terminal. So these two in parallel, then 24 kilo ohms in series, and then 320 ohms in series as well will give us 52.32 0.32 kilo ohms.